Hello, in this lecture we shall discuss in brief the Barkhausen Criterion, which is a very primary requirement for an oscillator to produce sustained oscillations. We know that in the case of a positive feedback amplifier, or you can say in the case of an oscillator we use positive feedback. So in that case, AV prime is equal to AV divided by 1 minus beta AV. And the first and the foremost Barkhausen criteria is that for an oscillator to perform oscillations without damping or to have sustained oscillations, then beta AV value should be equal to unity. So that means beta AV, when it becomes equal to unity, you can say that AV prime becomes infinite, that is 1 by 0, 1 minus 1, 0. So this becomes infinite. So this means that the gain of the system will be infinite even without an input, because AV prime you can consider that as VO prime divided by Vin. So this basically infinity means that even without any input signal you can get very high gain. So that is the case of an oscillator, because you don't give any signal there, but then you get output with high gain, or you can say you get oscillations in the output without any input signals. But then we shall understand what this basically practically the situation is that beta AV, theoretically we have to say beta AV is 1 in the case of a oscillator, but then practically beta AV may be less than, or you can say cannot be exactly equal to 1. So let me take this beta AV less than 1. So first we'll see if beta AV less than 1. So if beta AV is less than 1, which means that let me consider the beta AV value as something equal to 0.9. So then we can say that if that is 1, this beta AV can also be written as, we know that AV is what? AV is VO by Vin, right? So I can write this beta AV as, or let me stop here. Let me first write what is VF, feedback voltage. That is actually VO divided by feedback voltage is actually beta times VO, right? Beta times VO, and this VO can be written as AV times Vin. So this VF can be written as beta into AV times Vin. Suppose our input voltage initially, that means initial voltage, whatever it be, so whatever something will come at the initially there should be some input signal, right? So that signal is not something which you apply, but it is something which is generated when the supply is switched on because of the inherent voltage within the circuit, not because of something which you give. So that input voltage initially is actually set up due to the input voltage which is present due to the biasing which you give and all the thermal noise which is there in the system. So let that be 2 volt, suppose. So if that, when you give that 2 volt, VF becomes equal to, so that I can write it as VF equal to beta AV is actually 0.9. We said that is less than 1, so 0.9 into the input voltage is 2. So you are going to get the feedback voltage as 1.8 volt. So here you can see that the feedback voltage is lesser than the first input voltage. So if that is the case, each time then the input voltage then becomes this one. So each time when you calculate the VF voltage, it is going to decrease like this. So that means you are going to get damped oscillations. So it will produce oscillation initially with a high amplitude, then it will go on decreasing and you will get damped oscillation. So for otherwise for you to get guaranteed that the oscillations doesn't damp, what you have to make it that the other way, that is beta AV should be greater than 1. So if beta AV is said to be less than 1, you can say that oscillations produced will be damped oscillations. And it is always fair to have the condition as beta AV equal to 1, but then this is a very strict condition that beta AV exactly becomes a one particular value may be quite difficult practically. So you can set it something somewhere around some value or somewhere greater than or less than. But if you keep it less than 1, you can say that you will get damped oscillation. And if you are going to keep it greater than 1, you can just work out. So for example, if you can make suppose I take this beta AV set less than greater than 1. So let it be equal to 1.1 then, which implies this beta AV is equal to 1.1. Then what is the VF going to be? VS is beta AV is 1.1 into the voltage which you give to, that is 2.2 volt. So that means actually VF feedback voltage is increasing with respect to the input voltage you give or input voltage which is there. So which means that the VFS increasing means that every time you are going to, your oscillations will not die, but your oscillations will actually speak, it will actually gain its amplitude. But then that is more better way so that you get oscillations without or sustained oscillation. So actually what it is done is initially this beta AV value is said to be greater than 1. Then after some time in the damping or it has maintained a particular oscillation, then the oscillations may maintain to be steady, okay, by keeping it something lower than that. So that is what is happening in the case of, or we say that when beta AV is equal to 1 or beta AV should be greater than 1. So I hope you understood why it is strictly said that it has to follow this particular condition for getting sustained oscillations. So now I can consider the first and the foremost condition which is set in the Barkhausen criteria as per the Barkhausen criterion, that is beta AV should be equal to 1, or practically speaking it should be greater than or equal to 1. And the second condition is that the uh, the output or the feedback network produces uh, produces a phase shift of say 180-degree. Suppose we have an amplifier here and you give a signal in this way to the amplifier. Okay, this is amplifier, and you can say that after amplification you get an amplified signal, but it will be in the phase reversed mode, that is here. This will be your amplified but inverted signal when this signal is actually fed back to the feedback network. So if this is the feedback network, if the feedback network produces a 180-degree phase shift, you get the signal in this way itself, right? So again get shifted to, or again this signal get phase reversed. So now you can see that the input signal which go when previously, and that is in phase with the feedback signal. So when they go in phase with the feedback signal, or when the input signal goes in phase with the feedback signal, you are sure that you get actually positive feedback. So that means one important thing for an oscillator network is that the feedback network should produce a phase shift of 180-degree, so that what we mean is that the input signal and the feedback signal, they go hand in hand, or they are in phase, or 0 degree or 360-degree in phase. So that means you are sure that you will get sustained oscillations, or you get oscillations because of the positive feedbacking. So these are the very important two criteria which is required for oscillations to produce, or oscillator to produce sustained oscillation. One is beta AV should be equal to, or it should be at least greater than or equal to 1. Then second thing is that the feedback network in the oscillator should produce a phase shift of 180 degree with the output signal, so that finally the input and the feedback signal go in say in the same phase. So this is all about the Barkhausen criteria. Thank you very much.